This is the last part of section 14.7. We're going to do two compositions, one of them with repeated parallel lines and one with repeated angles. So on this first one, we're going to reflect this triangle over x equals 0, which is the y-axis here. And then we're going to translate it, or the new one, over the line x equals 8. So we'll start with this one. If we're going to reflect it over the line x equals 0, that means it's just flipping this way. And mathematically, that means the distance to the y-axis needs to be the same distance on the other side. So this will become b prime. A is 1, 2, 3 away from it, so 1, 2, 3 this way. That'll be a prime. 1, 2, 3, 4, 1, 2, 3, 4. This will be c prime. So there's our second triangle. Now we will reflect it over the line x equals 8. 1, 2, 3, 4, 5, 6, 7, and 8. So we're going to treat it just like we did here where we flipped this one over here by counting the distance of the difference, the distances to the line. Well, we're going to do the same thing. The distance is here. This is 4 spaces to it. So it's another 4 to where C double prime is. A is 1, 2, 3, 4, 5 away from it. 1, 2, 3, 4, 5 that way. That's A double prime. B is 1, 2, 3, 4, 5, 6, 7 spaces away. So 1, 2, 3, 4, lost my count. 1, 2, 3, 4, 5, 6, and 7. So that will be B prime. And so it flipped to here, and then it flipped all the way over to there, and that is the new triangle. I could ask you to give me the coordinates of them, or to do it physically like this. If I asked you for, say, the coordinates of C double prime, you'd be looking for 8, 9, 10, 11, 12, and 2. Now, let's take a look down here. When we're talking about repeated angles, we're going to reflect ABC over an angle, and then another angle. Now, unless it says different, you reflect them counterclockwise. So that means doing a 30-degree angle from this line here, or actually for each other. It's to each one of them, to the origin. And you're always going counterclockwise unless it specifically says clockwise. This one doesn't say clockwise, so we're going to counterclockwise. Well, that means we need to treat it just like we did with rotations. And so I am going to have to set up the center here and line it up with A. Nope, I just realized I'm planning on a rotation, whereas what I need to do is do a 30-degree angle. So let's rethink it. I was thinking that first and then moved into rotation mode. Well, rotation mode is not what I needed to be in. So if this is 0, and I go up to 30, 30 is about here. So a 30-degree angle from the x-axis using the origin as the vertex is going to be this one. While I'm at it, I might as well also do the 60-degree angle. Well, actually, let's think of it as two 30s, since that's the way this is written. A 30-degree angle, then another 30-degree angle. So I'm going to line it up here, and then 10, 20, and 30. Could put it down here, or I could put it here. It doesn't matter, as long as I then come here, and I do this. So, instead of thinking rotation, which is why you have to be careful, you see how easy it is to start thinking about one of the other ones. So what I do is I have to set up each one of these with a line, again, just like the other ones over here with parallel lines. I have to go to that line and then the same distance on the other side. The thing is, it needs to be a right angle. Well, I can use this to my benefit. The number 5 here on these if I hold it this way, you can see that 90 degrees here is right all the way to the number 5. Well, this is a well-worn, used one. You can tell some of it's rubbed off a bit. I'm going to try a different now. I like the green one. It matches my name. But this one at least has actually more stuff on it. So I notice on this one that not only does the 5 line up with that, so does the 3. Those are at 90-degree angles from here, or is perpendicular to those. I'm going to use that to my advantage. And so I am going to set this up. If I go here, see how now I see where that line would be that's 90 degrees here. Well, what I also want to do, and so I either need to keep it that way or I need to do a little like, let's see, if I set that up, I am going to set it up so the 5 and the 3 are on the dashed lines and it goes through the A. Now I know, I need to make sure you can see it. I am lining up the A with this, but I'm making sure that the 5 and the 3 are on the dashed lines. Now this is a perpendicular line. Okay, so once I do that, and you can sort of eyeball it and see which way it's going, okay? And it's hard, I can see it goes to about there. So now I'm going to take the distance from A to the line that goes through there, so that's pretty perpendicular. Okay, it looks like it's 12 or 13, it looks like it's 12 millimeters. So then I'm going to move up here and I'm going to go 12 millimeters. About there. So right about here is where A prime is, because if I did this as a line straight to it, now you can sort of eyeball it, but you really want to keep to as much as possible to a right angle thinking. I can now come over here and do that same thing right angle wise. It looks like it's going to be up to about here. Let's measure. From B to the line is 1, from here to there is 1, and I'll put a B here. So if I go like this, it really looks like these two lines are parallel. I'm going to do the same thing with C. Only this one's a little harder to set up, so I think I'm going to go back to line it up and make sure I get a truly perpendicular line. Now, I'll then take advantage here is another way to think about using these papers, or when you're doing it. That means that this line, well, it's not quite on the C. There, now be as precise as I can be. If I go way up here and put a dot, now I know perpendicular from C to that. But I don't need to draw a long line there. What I need to do is line it up with that dot and put C towards that dot and measure the distance. It's just under 2 centimeters. Now I'm going to continue to come up here, line up with that dot and go just under 2 centimeters. There's C prime. So this one flipped over to that, and see how when it's away from the x-axis here, the A is closer, the C is not. Up here, the A is closer to that line, the C is not. And now we're going to do it again. We're going to flip over this line. Well, I want to do the same kind of right angles, but this one's so close that I can just sort of eyeball this here. Okay, if that's there, this needs to go right up over it. Let's see if I can get that pretty close. It seems to be pretty close. Okay, still want to, I can't completely eyeball it. That distance is here, and then the A is going to be over here, because it's going to be the same distance. So it looks like A double prime will be right about here. For B, and I want to make sure it's a perpendicular line going through B. 3 and the 5. Line up with it. Put a dot way up here. And now I'll measure. 0 and towards the dot. That's about 15 millimeters. Maybe, oh no, 1 is about 12 millimeters. Maybe a little less, about 11 millimeters. Now that I straightened it out. So now I'm going to go towards that line. And I'm going to do 11 millimeters. Or hopefully pretty close there. So B prime. C prime will do the same thing, but now this one, you know, that's perpendicular, that's perpendicular. Let's go this one, it looks like that would be perpendicular. Do about that same distance. And that's where C double prime is. And then I can connect these lines. And it looks reasonably close. My own drawing's the problem there. This flipped over this angle line. This one flipped over that one. Okay. So that's how you reflect it over one angle, or over a 30-degree angle and then over another 30-degree angle. So 30 degrees from here, from this sort of baseline for this one, and the baseline for this one was here. Okay. So you flip it over parallel lines, you can flip it over angles based on the lines that are going off of the rays, I guess I should say, the rays that are going off from for the 30-degree angles.